Alright, so in this video we're going to look at solving linear equations. So essentially there's three methods to solving linear equations, right? We can either graph them, we can use substitution, or we can use elimination. Okay? And there's going to be, each one of these methods has its own scenario where they're going to be the most effective, okay? And let's start off by looking at substitution and elimination first, okay? So, substitution versus elimination. You want to use substitution when it's really easy to isolate for one of your variables. Okay? So, in the case where we have y is equal to 2x minus 3 and something like y equals negative x plus 7. Okay? Do you see how in this case it's really easy to isolate for x? We just have to move it to the other side, or even y, right? Because we have these two alone. So it's very easy to substitute one of these y's and make these equations equal. So negative x plus 7 is equal to 2x minus 3, right? And the reason it's so easy to do that is because we already have y isolated on one side. Substitution is going to be a great method for that, right? When we use elimination, well, it can be set up very similarly where we still have y isolated, and this is just called slope-intercept form. You'll see most of your equations like this. But the time you'll do this is when you have like 2x and negative 2x, right? So you see in this case, we can just add these equations together, right? And this would be something like 2y, right? So we just add these together, or we don't have to do 2y, but yeah. So y plus y gives you 2y, right? 2x minus 2x gives you 0x or nothing, and then plus 3 plus negative 7 gives you negative 4. Right, so we're left with this equation where 2y is equal to negative 4, or y is equal to negative 4 divided by 2, which is equal to negative 2, right? So that's kind of going to be when you want to eliminate, when it's really easy to just add the equations together and get rid of one of the variables. Substitution is when it's really easy to isolate for one of these variables and just replace one of the y's with whatever it is. Okay? Graphing is something we can always use, but it's going to be the most time consuming one because we have to actually sit there, draw out the graph and the intercept and the slope. But let's look at an example of when we would use it, right? So first, we have y equals 2x plus 1, y equals negative x plus 4, okay? So, as we know, we can just equate these two to each other to solve it and just say 2x plus 1 is equal to negative x plus 4. But let's solve this one out by graphing it, okay? So we're going to start by just drawing out our graph. Okay, and let's draw out 2x plus 1 first. So this plus 1 means our intercept is at 1. Okay, so this y-intercept comes through at 1. Okay, and then every time we rise 2, we run 1. So rise 1, 2, run 1. Right, and that shows us our slope. And just with these 2 points, we can draw out our whole line. Okay, so that's 2x plus 1. Same thing we're going to do for negative x plus 4. So instead of having our intercept at 1, like here, we're going to have it at 2, 3, 4. Okay? And let's label this one really quick. 2x plus 1 is this line, and then this line is negative x plus 4. So every time we rise negative 1, we run 1, right? So we're going to go here, here, so on and so forth, right? And that's going to be our other line, which is negative x plus 4, right? And whenever we're solving a system of equations, all we're looking for is the point where they meet. And already here you can see when x is equal to 1, that's where we meet, and y is going to be equal to 3. We can prove this algebraically as well, same way we did before, where we would write 2x plus 1 is equal to negative x plus 4. Okay? We would bring this x over here, so we would have 3x, and we bring this 1 to this side, so we would have 4 minus 1. And we would have 3x equals 3 divided by 3 divided by 3, therefore x is equal to 1, just like we got when we were graphing. Okay, and then to find out what y is, you would just plug it back in. Y is equal to negative x plus 4, so negative 1 plus 4 is equal to 3. And just like that, we found out the exact same answer. These lines meet, when x is equal to 1 and y is equal to 3, or at the coordinate 1 and 3. Okay, so all these methods will work as long as the math is correct. Okay, and then now it's telling us there's an equation that we can set up and do elimination. Okay, how are we going to do that? Y is equal to 3x minus 7, and then our other equation is 2x plus y is equal to 11. The way we're going to set up elimination in this scenario, let's isolate for y, so let's move this 2x over here and have it be 11 minus 2x, right, and get rid of this positive 2x. Now we have y is equal to 3x minus 7, and y equals 11 minus 2x, and if we subtract these equations from one another, right, let's see what we get. So y minus y equals 0, 3x minus negative 2x is 5x, and then negative 7 minus 11 is going to be negative 18. So we have 18 equals 5x, and then 18 divided by 5 equals x. Cool. And then we would just substitute that back in for our y value to solve for what it is, okay? All right, and then last one is substitution. So you want to isolate for one of the variables and substitute it out. So we have 5x plus 4y equals 19, and 3x minus 4y equals 5. Okay, we can substitute for either x or y in either equation, just whatever one you think is the easiest. In this case, I'm going to go through like this and say 3x equals 5 plus 4y. So x is equal to 5 plus 4y divided by 3. Okay? Once you do this, you take your first equation, or the equation you didn't use, 5x plus 4y equals 19, and you're going to substitute out this x for everything we just solved x to be, because we know these are equal. So 5 plus 4y divided by 3 instead of this x here, and then plus 4y equals 19. And what this does is it makes it so we only have one variable in our equation. So now we can solve for y. So how can we do that? So 5 over 3, or we need to basically get y out of these brackets, right? So way we can do that is go over here and isolate for y. So we can start that by just distributing that in. So 5 times 5 is 25, right? 5 times 4y is 20y. And this is all still divided by 3. Plus 4y equals 19. Okay. We can move the 4y over to this side. Have it negative 4y plus 19 is equal to 25 plus 20y divided by 3. Multiply both sides by 3. We can cross this out, and we have 25 plus 20y is equal to 3 times negative 4y is negative 12y. 3 times 19 is 24, 60 minus 3, so 57. Okay, and now let's bring the y's to one side. So 20y plus 12y, since we're moving this negative to this side, it's going to be 32y equals 57, and this is going to become negative. 57 minus 25, so we have 32y equals 27. So 32, or 27 divided by 32 equals y. Okay. So that's an example of each substitution, elimination, and graphing. And you can use any of them, but it's just a few times when one is going to be easier than the other whenever the equations are set up for it. And it's important to understand when they're set up for it. And yeah.